There we go. Right, thank you all for coming along, and thank you, Con, for that very nice intro. I'm going to talk about dependency injection and specifically why I think you should ditch the frameworks that you're using. And this, I think, will be a novel point of view to many of you, and I hope that it will challenge some ideas. And I also want this to be interactive because if I don't produce some disagreements, then I haven't done my job here. I'm not trying to be a troll, of course, but I hope that we have a good discussion here. So please do interrupt and please do raise your hand if you've got something to say as we go. I'm talking about, I'm going to use Spring as an example, but it could be Guice, it could be Dagger 2, which is the one that the Android people like. By Spring, I just mean the IOC container and not the other 900 things that Spring does. So I'm going to argue that the problems with DI frameworks are there is too much cognitive overhead. It's a $50 solution for a $5 problem. There are confusing semantics. They smear application level responsibility all over the application. That's going to be the main thing that I'll be talking about. Makes it too easy to not think about responsibilities, makes it harder to reason about code in isolation, and throws tech at a problem that shouldn't exist. And I'll go through lots of examples and that sort of thing to cover off that. What do they solve though? So this is the claims, some of the little sound bites from the pages of these frameworks. Factories aren't fun. Dagger 2 says replace factory classes, so no love for factories. Assembly can take up an awful lot of code, that's certainly true. Think of Guice as injectors the new, so it's not very good to have new in our code, so it can replace that. And Spring talks about initialization ordering. So I'm not terribly impressed with any of these justifications, and we're going to take a little bit of a trip to the daisies, and we'll cover some of these. They bring a lot of concepts in tow, and I don't think I'm being unfair with this slide. These are all terms of art that appear in the first few pages of documentation for these frameworks. I mean, it is a conceptual burden. You need to sort of learn this stuff to get across them, and that's not free. I sort of see this as the problem and the solution. It's just passing over this. Now, I am being a little bit trolly here. A less trolly version of that might be, it's not just that we're passing over this of things, it's that some of the arguments don't vary with the same kind of frequency as some of the others. So some of them we only want to choose once at the start of the application, and it would be terribly wasteful to drag them all around and keep choosing them over and over and over again when really we only want to choose them once. And the answer, which I'll argue for, is only one place in the entire application should know that it's in an application. This is the application wiring place, and that's where you wire up all the things that never change. And then we use good software engineering practices to reduce the number of things that need to be wired together. So we think of it as wiring together floors in a building, not bricks in the wall. This is what I'll go towards. Let's build up this dependency problem from scratch. So I'm going to use this case study. It's a bit of a silly case study. Imagine like a Blockbuster video store or something, except they have a website because it's 2018 and they're not bankrupt. And they have a web application, and this is like an API or something. And you've got your controllers up here, and then you've got business model stuff that does stuff, and then you've got some infrastructure stuff down there, which is a fairly ordinary kind of thing. I'm sure this isn't a perfect design, it's just whatever I came up with late at night a few nights ago. But they all are in objects, and let's imagine what it was like if there were no objects. So we're just listing the functionality that we want, the things that we want to do in this application. We want to handle a rental request, and to do that, we want to rent a video. And then to do that, it wants to charge the credit card and find things. They're things we want to do. The code for this might look like this. So we've got a static method, rent video, and we see that it calls other static methods, charge, find similar, and that sort of stuff. I think most people would say this is not very good code. How do you feel? Is this code that you would sign your name to?
No.
No, thank you. Very good. Why? Anyway.
You can't change the payments implementation or the...
Yeah, exactly. Yeah, so it's coupled to stuff that's in the inside. You can't talk about this video without coupling everything to the stuff in there, and that makes it hard to test. So this is a problem. So what happens is eventually we get to this sort of I/O boundary, and we sort of need an object here. This thing needs a database to run. But now, because everything's getting passed in these functions, we don't have any other structure, then these things have to sort of pass it down to, they have to take the parameter themselves to pass it down, and then the things above them need to take the parameter to pass it down again, and we get this thing where our concern at the very, very bottom layer is bubbling all the way up to the top, and then it's got to get trickled all the way back down again as a value. And then if we have a payment gateway over here, same deal, and we're in a real bad place. This is very bad. I'm sure this won't be controversial. So that's punching through abstraction layers. We've got something that belongs at that bottom infrastructure layer, and everyone's got to know about it. It's going to ripple. If you want to change anything, it's going to ripple all the way through the application. All those DBs are all getting supplied for the same reason, but we've got to do it in these multiple places and multiple times. So that's really, really bad. I'm sure you all agree with that. I don't think that's controversial. Yell out if you do. Yeah, good. Correct answer. So what happens here in our imaginary example, where we had all these static methods, we find that we need to actually put them in an object. So we need to have something that is a video repo, and then the next one, now we have a video searcher object that knows about the video repo. So only the video repo knows about the database now. The next thing knows about only the thing below it, and so on. And so the objectiness bubbles up, and because the thing below it needs to be an object, then the thing above it then needs to be an object, so it can be parameterized with the thing below it. So we need to create all these classes and wrap all our functionality in objects so that we can avoid that horrible situation we were in just before. And so that all just bubbles up to the top. And great, now everything's in classes now and everything's in objects, but we have avoided that bad situation now. So I'm calling this object creep, where putting something in an object, it buys us flexibility, but it adds a little bit of complexity to the functionality that we really want to call there. Isn't that okay? Well, sure. So let's look at a more sensible implementation now, where we have final dependencies, final fields containing the dependencies. You can imagine the constructor and functionality that does some sensible video thing. And so I'm going to call this a code hanger object, in the sense that the existence of this class is kind of a coat hanger to hang the functionality on. But the functionality is locked, and the key is the dependencies. So if you want to run video, or you want to compose it, or reuse it, or rearrange it, or test it, you need to unlock the lock with this key, which is you provide those dependencies. But then, let's say, if we look at Video Searcher, that itself has functionality inside it, which is the thing that we really want, but to crack it open, we need another dependency and so forth. So what we kind of get is this network of lockboxes, and the functionality, which is the stuff that we really care about. It's the stuff that we want to run. It's all locked inside these lockboxes, and it's difficult to compose and reuse with respect to each other. So there is we have paid a price. We've gained a good thing, but we've paid a bit of a price there. So there's a question then: can we reduce the number of objects we're using in the system, because that does induce a certain amount of complexity here. This is the bit I really wanted to talk about. This whole thing about dependency injection frameworks is just an excuse for me to talk about responsibilities. You need a place in your application that knows it is an application. And that's the thing that does all the wiring, that says, well, we're not just having a data store here, we're specifically having a MySQL database with such and such a connection pool and such a connection string and such a thread details. And I know that because I know I'm in an application and I know what it's for. And everything else in the application doesn't know that. So you end up with something like this. And what dependency injection frameworks do is you don't have to write that. And the extent to which you think that they're purchasing something valuable for you is the extent to which you don't want to write that code. And that's quite understandable. It's not the most fun code. Greg Kick, the creator of Dagger 2, he says, well, some people say, yeah, I can manage it myself, but at Google, we have an Android application with 3,000 lines of code, and then in a large app, there's 100,000 lines of that kind of code, and that's horrible. Sure. So I guess to that I would say there are techniques that mean that we're not wiring together thousands of things. We can reduce the complexity of that code. I have no idea whether that's applicable to their code bases. The other thing I'll say is Greg has Google problems. I don't have Google problems, and neither do you. So that's what I say to that. So this code, this is the one place in the application that knows it's in an application. And I will argue that this is essential to reducing the complexity of your application and managing proper responsibilities. If you have a big system, if you have a system with 1 million components, and you only have to fit 5 of them in your head at a time because they're well separated, that's a simple system. But if you have a system with 20 components and you have to think about all of them at once and fit them all in your head, that's a complicated system. And so it's essential to have a separation of concerns. It's essential to have clear responsibilities and not have your whole code base know about application level concerns. So DI frameworks help us reduce code in that one spot, but the I know I'm in an application thing is smooshed all over your code base. Especially with annotations, as nice as they are and as easy to use as they are, that's what ends up happening. Does anyone feel violently ill yet, or are you with me so far? Okay, all right. Don't worry, we'll fix that shortly. It gets progressively more controversial. Okay, here is the rentals class again. And so we want to make sure that this has clear responsibility. It exists for a reason, and one reason alone. Who am I, what do I exist for? And a question that I really like to ask, and my life just got so much easier once I started doing this. I do this with almost every bit of code I work on, especially when I'm stuck on the design of something. What is the problem that makes me say, aha, I'm going to use that bit of code to solve my problem? What is that problem? So I find this a really, really helpful thing to ask, to help clarify design questions in a class that sort of, you can't work out what it's for. So the answer is quite clear, I think. Use me if you want to rent a video. Sure. It has no idea what an app even is. It doesn't know what a database is, it doesn't know what an application is. All it knows about is renting videos. Now, having a constructor with parameters, that says something too. And what that says is, I don't care in the slightest which instance I get in the constructor. I do not care. I will do what I do. I will do my job no matter which instance you give me. What I have to do, I need that functionality, but I just don't care which one. So,
you're bubbling again, though.
Oh, say that again, sorry?
You're bubbling again, though.
Yep, so the comment was, you're bubbling again, though. Well, here I'm not. It's just immediate parameters that are immediately needed for this functionality.
You're going to have to pass the logger around everywhere.
What does everywhere mean? So the comment was you're going to have to pass the log around everywhere. What does everywhere mean?
To other objects that it's going to instantiate.
So this class doesn't know anything about any of the rest of the world. This class is a closed universe. All it knows is its job is to rent a video and return a receipt. And it knows that in order to do that, it requires 3 things. So, there is no concept of the rest of the world here. Yeah, does that, I'll cover more stuff. I'll probably get to things that'll colour in your point. So, yeah, thank you for speaking up. This is what I want. Sure. But now we've made a very small change. We've put components at the top. And what that does in Spring, that says if other things are looking for a dependency, you can find the one true instance under the name Bob. So now that is making a claim too. That is telling us something about this class. And it's saying not only that there's a thing called rentals, it's saying there is one true rentals. There is a singleton that is the one true one, and we want it to be created and we want it to be called Bob. And the other thing is saying, well, I want the video searcher, the payments, and the log defined for the app. That's the claim that's being made by AutoWire here. So that's an application level thing. And you might think I'm clutching at straws here, but bear with me. So let's make it a little bit more interesting. Let's say we have an interface video searcher and payments, and there are actually many different implementations that we might choose. And let's look at this again. Now, so the existence of the parameters again, what that says is, I do not care in the slightest which instance we have for me to do my job. But those qualifier annotations, what they're saying is, I care exactly which instance is provided. I'm specifically choosing the internet search one, I'm specifically choosing the credit payments, and I'm specifically choosing the log4j. Why? What are those concepts? What do they mean here? Well, they don't mean anything in the context of this class. Now, so in the programmer's mind, there is no longer a separation between what this class is for and you know, the broader application. And there needs to be. To write a simple system, to write a big system that is simple because everything doesn't know about everything else, you need this clean separation of responsibilities in the code that you write. Yeah, how do you, are you with me so far? Yeah, sure. So, the point is, use me if you want to rent a video. Therefore, what it does to rent a video, the point of it is, firstly, we decrement the stock, we charge the credit card, we log an appropriate message, and we return a receipt. If it does those things, it's done its job. So how do we test it? Well, testing a class with clear responsibilities is the easiest thing in the world. We check that the video store got decremented, check that the payment got charged, we check that the logger received an appropriate message, and we check the receipt. So these all things align exactly with our purpose. And so TDD can kind of help here because if your purpose is not clear, if your responsibility is not clear or blurred, or you have somehow taken on application level responsibilities alongside your class responsibilities, the test will be hard. And you'll find yourself tempted to use things like mocks and stubs to cut your class to ribbons to try and extract the bit that makes sense out of it. So it might look something like this. We create the things we need and we run the functionality and check the thing. So yeah, it's the easiest thing in the world. So what's happened there is that the application, what we looked at was that there was a problem where the application level responsibility bled into the app, and where we didn't have any of those things, we found that with a clear sense of responsibilities that was very, very easy to test. But we can get the other situation too, where the class responsibility bleeds into the app. So this is a thing I see quite often as well. Now, instead of having something that lets us decrement the stock and charge the credit card, what we have now is a dependency called stuff that happens first. And in rent video, we run the thing that happens first, whatever that is. And in the qualifier there, in the dependency injection Spring layer, we're saying, well, we specifically want the thing that decrements and pays stuff. Yeah, question?
You know, Spring lets you define beans at a higher level. I mean, but majority of the time I use Spring, the beans are unqualified. Occasionally you do want different implementations. Why not advocate to instead of advocating for not using DI frameworks, don't advocate for not using qualifiers?
Sure. So the comment was you usually don't use qualifiers in your Spring code.
And when you do need them, you can
so you can
do
use
it at a higher level rather than at the actual.
Oh yeah. This is by no means an example of code that you should emulate. And I should point out that I'm not arguing that you can't write good code with dependency injection frameworks. My point is simply that you don't need them, and that they have a tendency to lead developers and teams in the wrong direction. And so this is an example of something that I see a lot, which is because in the programmer's mind there is not a clear separation between the application level responsibility and the class level responsibility, they've abrogated. Is that the word? That's not the wrong word. They've given up some of their rightful responsibility here and given it up to Spring. And so Spring is now the thing that says, well, we're specifically going to decrement and choose the one that decrements things and pays stuff. Yeah, question.
My Spring's pretty rusty, but in earlier versions before auto wiring, didn't this get defined in XMLs?
Yeah. So it's this is a lot easier to show on a slide.
Is that the compromise they're making? They're saying that it's worth inlining it at the sacrifice of not doing XML.
Yes. So the comment is in earlier versions of Spring it was all in XML, and how does that affect this example? Is that But,
I know, what I'm saying is they've made a compromise putting it inline,
yeah.
which breaks the.
Sure, yeah. Okay, yeah. So annotations, despite being much less verbose and really nice to look at and easy to use, are worse in some ways than XML because of that, because they are sort of jammed in line in the class.
Well, it's inline, yeah.
Yeah, but it's the same. Like you can get this same thing in XML. Now, I've seen it where stuff that makes this do its job is in XML beans, and this thing itself is just like this lifeless puppet with Spring pulling the strings, and like none of the classes know anything or know what they're there for. They're all just getting pulled around by Spring, and so this is a thing that can emerge. And XML, it's the same with XML in that respect. Yeah, does that make sense? Yeah. Oh, cool. So again, it's harder to say that the point of this is to render video because so much is just left out. There's a whole bunch of stuff happening here that we don't really know what's happening, and we're leaving it to Spring to decide what we do. We're relying on the kindness of strangers. So this is another anti-pattern that can sort of, it's very easy to emerge using a DI framework. How can we make less things that need wiring? This is a really important point because a lot of code bases I see, or code bases, have too many things that are being wired together. Now you won't like this one. I expect some resistance on this point. What's wrong with you? Tell me. What's wrong with you? Yes.
Mr. Avery talked about this one in earlier presentations before Angular. It was a
Yep.
really good presentation for Google Code Talks. But he talked about dates specifically, and if you new date things all around the system, you can end up with really problematic slight differences in calculations.
Right, so if you do new dates all around the system, you can end up with problematic differences in calculations. Yeah. Anyone else?
Ties you to
Implementation.
Yeah, that's the big one. Yeah, so it ties you to an implementation.
Yes.
So these things are all true. However, let's burn the whole thing to the ground and start from something incredibly trivial. If you went to my talk a couple of years ago, I used a similar example that you might remember. So 1 plus 4 times 5. This is a program where there's a data structure called int, and there are two methods, plus and multiplication. So in an OOE sort of way, it would look like that. And with object creep in an application, it'll end up getting turned into code hanger objects. So now we have new adder dot add, new multiplier dot mult. So the multiplier looks like this. So I'm going to throw this at you. So we're creating an adder. We're creating our own one with new. And in the implementation, we're starting from 0, and then we're over and over again, we're using the adder to add the numbers that many times. So the effect we produce is multiplication. Is that bad?
Yeah, you got threading issue there.
Oh, is it say that again, sorry?
You got threading issue.
Got threading issue? What's it?
So if you create a multiplier, you've got the same adder, and then you add that on the multi.
So if I create another multiplier, then I have the same adder.
Yeah.
So I think so I think we can assume for this that the adder is just a thing that just does addition and it doesn't have any state or anything. So if you create each multiplier you have will have its own adder, but whatever, they're all the same for the purposes of this
It's
exercise.
exactly the same thing in a live system, and it costs millions of pounds worth of damage.
Oh, how so? So what's the problem?
Because if you were using the same adder, you got a multiplier, same
It's not
multiplier.
static.
It's not.
It's not static.
It's not static.
It's not the same adder. It's every multiplier will get another
Different.
new instance of it.
Right, yeah. Okay. So each one will get a new instance. So is the suggestion then that
If you were using the same multiplier object from that one, every time we call a mult, you're using the same adder to add up to the rest of the inside mult.
yeah, okay, sure, okay. So every time we call mults, we're using the same adder. So yeah, this doesn't matter if adder is stateless. So my assumption here is adder is exactly what it sounds like, and it's stateless, which means that it doesn't really matter which instance we have.
What if other classes want to use adder? They also need.
So say again, sorry.
So if this is the case, then if my another class needs an adder, it will initiate one more object. We are not reusing the object, right? If we use DI, we could pass the same adder as an argument to different classes. So we just have one instance of adder if it's just a utility class.
Yeah, so I mean, we could have one instance of adder if we wanted, but that's a efficiency thing. Like, I don't really care about that. So like, caring about which instance you have is a feature of classes with mutable state. So if your class doesn't have mutable state, then it doesn't matter if you've got the same instance or different instances. Like, that doesn't matter. So in this case, so my assumption here is that adder is stateless. It's just a thing that performs addition. It's a code hanger on which we're hanging addition, and therefore, like, maybe it matters in terms of memory usage or something. In terms of, like, every multiplier we creates another adder redundantly when we could. I don't know, whatever. I don't care about that. But yeah, but it won't produce incorrectness in this case. But that's why it's a call out. Like, if this had some crazy implementation, then, you know, things could happen. Now here's another one. So this time we're doing it a little bit differently. This time we're taking adder as an argument, and the multiplication thing is the same as before. Is that better or worse? What's the difference there? So this is the first one. We're creating our own adder and using it. The second one, you give me an adder and I'll do stuff with it.
You're avoiding the object creation, so it's more efficient.
Yeah.
Avoiding it. Well, someone's got to create the object.
Only once.
Yeah, only one.
Okay, yeah, that's true.
Potentially only once.
Yeah, that's true, but I don't care.
Well, only this side, but if you,
Java is super efficient at cleaning up objects. It's super efficient. We don't have to worry about that.
well, in this simple example, it doesn't matter. But if in complex example, if you want to have multiple implementations, then it does matter, right? You're not tying your multiplier. In this case, you're tying your multiplier with just one implementation of adder, right? But if you have multiple implementations, you can just change at one place and you can pass at different places.
Yeah, exactly what different implementation of add are you intending
I
to?
mean, not in this design. in a different complex app.
Sure. So look again. So what am I, oh yeah. Sorry, up the back. Yeah.
If I'm a user of multiplier, why I need to know you need an adder and I need to pass the adder to you?
Yeah, it's cool.
So if I'm a user of multiplier, why would I need to
Give you an adder.
Yeah.
Yeah, well, no good reason. So, I'll give you my opinion now. So, again, we want to ask what the point of this class is. You know, what's the problem we have when we say, I'm going to use a multiplier to solve my problem? And there is only one answer to this question. There is only one thing in the public interface. It's a multi-method, and clearly it's supposed to multiply two integers, right? So the problem you have is you've got two integers and you want to multiply it. This does that. As a user of this class, we have no visibility into what it's doing there with its new adder. We just the only visibility we have is that the int that's being produced by mult is the correctly multiplied int. So in this first one, the new adder, it is a tool that is helping us do our job, and that's fine. That's what I'm going to say. It is fine to pick your own tools to help you do your job, because that's what you exist for. And here the point is multiplying two ints.
About testing?
Sure. So, well, yeah. Who wants to weigh in here? How would you test this class?
Just as the public method.
Just use the public method. Exactly right. There is only the purpose of this class is to multiply two ints. There is only one way to test that. You take two ints and you use it to multiply them and check you get the right answer. That is the only way to test this class.
If you say though, if you've got multiple tools that you need to use inside your multiplier, and then you have a test that's testing multiplier, then you get an error in one of those tools, it's going to take you a lot more time to figure out where that error is coming from. You just know that the multiplier is broken, but you don't know if it's one of the tools or...
Sure, yeah. So the comment is if you have lots of tools that you've chosen and one of them's got an error, it's going to take you longer to figure out where it's gone than if you sort of snip them all out and you just put the code right here. So the choice of tools, I would say, is part of what this class does. And if this has chosen the wrong tool, like this class is broken in that sense. This class is responsible for whatever tools it chooses. It's responsible for that method signature right there, end to end. That's its KPI. Yeah.
So which adder do you test it with in the unit test?
Which what? Sorry.
Which adder do you inject to test it with in the unit test?
What injects? This is a private final field that's been
In the other
created.
example.
Oh, right, the other example. Ah, yes, well, sure. Well, that's the
The main
thing.
of that adder is the fraction adder.
So let's look at that other example. Now, again, having a constructor parameter, that's saying we do not care in the slightest which instance we have. Yeah. So what that's saying about this class, it's no longer saying that the point of this class is to multiply two ints. Because there's a whole part of that process that we're subcontracting to some random stranger in the outside world. So we can't call this a multiplier in any meaningful sense now. Now its purpose is to perform an action on a series of ints a given number of times, or something. That's all it does. So maybe we could give it a name like int-action performer or something, because that's now what it does. So, but that's what we did by putting in this extra dependency, by taking this thing that was new and turning it into a constructor parameter. We totally changed the responsibility shape of this class. So if what we want here is something that is responsible for multiplying two ints, we just broke it.
Yes, you could have just lived without the adder in that case. Just done a simple.
Yeah, like this unit.
Not even this one. Why do you need the adder itself? You can still write the code of multiplication inside the multi method. That's why you wrote it, right? Without using the adder.
Oh, sure, yeah. I mean, for argument's sake, I'm just using this as an example to say, here's a thing like with the points, and it uses a tool to implement that.
I'm saying that is also one other way of doing it. Like you were saying that we can no longer call it multiplier. The reason because we are using something else.
You should not use only adder. It's just a multiply function, right?
But
I
that's
get it.
actually not required. And in general also, not for the specific case. In general as well, I could have still lived without an adder and could still have done the merge. I don't need adder
Reinvent the wheel.
specifically.
So you mean we could implement this
Yeah.
functionality without that?
Yeah.
That's what
Exactly.
the method says, right? It multiplies, so then should do that.
Yeah.
Yes, but I mean,
the point of this slide, of this example, is just that one of the questions we should ask ourselves is, when we consider what tools we need inside a class, we should be asking ourselves, do we need to make this choice or not? If we need to make it a choice, use this tool in this situation or that tool in another situation, then we might start to look at things like dependency injection or whatever else we can suggest. But if there is no choice, if there is only ever one thing that we're going to use new.
yeah, that's pretty much
It
it.
doesn't go against the interface-driven development concept.
I'm all in favour of interfaces. I'm not going to talk about it much today because I think it's just broadly understood that they're a good idea. And, I don't have much to add to that.
Yeah.
Yes, interfaces are great, but
Right.
I'm not going to talk much
This
about
goes
it.
against that, right? Once you start using new,
So, I mean,
it goes against the factory.
yeah, but how much abstraction do you want with addition?
Yeah, but
What are you
how
going
much how much loose coupling you want? That it's like there's a
Because
trade-off, right?
anyway, sorry, I want to come back to it because I'm not sure we've answered your question.
Pretty much. I mean, I would have now be interested to see how you go ahead with it. As in, like, my point is still the same. Why do
Sure.
you need an adder at all?
Yeah, it's just one of many ways that we could implement. Like it's a silly way to explain
If you ask
multiplication.
me for the solution, I would say just leave the adder completely. Do everything that the adder is doing in the method itself, because at the end of the day, that's what it's supposed to do.
Oh, sure, yeah. I mean,
Yeah.
sure, you could do that. You could do that. You could have that do it all in line. But in real code, you don't always want to do that. Sometimes you want to use things that take care of it, some detail.
You can. It might be a very complex tool, it might be thousands or tens of thousands of lines, you can't put it in line.
Yeah, exactly. So generally speaking, we can't do that as a rule. But here, obviously, it's very trivial. Sure. Okay, good. All right, let's continue. So, just by that simple change of not implementing a new thing and making it a parameter, we totally change the meaning of the class. And that may not be a bad thing, it just depends what you want. But you have to have a firm idea of what you want. If you want this to be a thing that multiplies two ints, you've got to take responsibility for that and not allow any wiggle room in the way that external third parties use it. If you want it to be a thing that, you know what, it's a way of folding a list, ints in, some way that we don't care about. Well, that's great. Now we have a thing that does that.
The modifier for pick of compound actually just doing that, so we gotta decide what the name of the
Right, so it's the modifier of public or private is giving it meaning as well. Is it?
Yes.
Yeah, sure. So, well, I mean, in all of these examples, I'm using private final fields, and public constructors and public methods,
Yeah.
because I consider that good hygiene.
Yeah.
Yeah, I mean, if something is the public interface, that is saying something about what this class is for, and if it's private, that's not making that same statement. So yeah, I agree with what you're saying, if that's what you mean.
If you have multiple dependencies, like here you have only added, added is dependent on something else, and then so on and so forth, then you have to create the first or second slide that you showed me, which had a bunch of creations would come in the picture.
Yeah, well, I mean, so yeah, okay. So the comment was, if Adder itself has lots of dependencies, then we'd have to create all these, fill in all these dependencies to have that. So there's two things we can say to that. Firstly, that's none of our business. We only want to use an adder that someone else gives us. We don't care about how it gets created. Yeah, that's just not even a concept for us. And secondly, to what was said earlier about interface development, we would at that point we would probably be saying what we're talking to here is an interface. The concept is the interface rather than some particular implementation of it. And then we wouldn't have to worry about that. Yeah.
So we are missing the Spring container specifics, like someone said, so Spring container can create the dependencies for us. Like Adder has dependency of the hub, so Spring container will take care of those things.
So yeah,
but
okay.
we start doing those kind of thing, which is not part of the business.
So Spring Container could take care of supplying that parameter. It could, but why? Why would we do that? The class is already correct, choosing its own tools on its own terms, and to the outside world, it's just a multiplier and nothing else. So what could Spring possibly add to that situation?
No, I mean, probably in this example, it's not required, but let's say Adder requires like a calculator or something else, like you have to, then you have to create 3 different instances.
Yeah, sure. Well, I have another example after this that's slightly more realistic. So let's move on to that. Yeah, GST price. So here's one that's so it's got a price that's the untaxed price. It makes its own GST policy, takes the price in the constructor, and then a bunch of pricey stuff that you can imagine. So is that good? Like, is that something we'd want to do or not?
Depends which country's GST you're trying to use.
Depends which country. Well, let's assume it's in Australia for argument's sake.
It's only good if you move the definition of the amount of GST, etc., outside the class.
Okay, yeah, it's only good if you move the amount of GST outside the class. Sure, yeah, that's something you might want to give yourself a little room for, sure. Yeah, anyone else? Does it depend on something? If we were to say it depends, what would it depend on?
So GST is different for different regions, different countries and stuff like that.
It's different for different regions, sure, yeah. But we don't necessarily, our software is not necessarily being written for different regions. We don't, that's ambiguous. So, but yeah, sure, that could be a factor. Depends, it depends on the fact where it's being developed for. So, what's the problem we have when we say, aha, I'm going to use a GST price to solve my problem? With the class as presented here. What was that, sorry?
So we need the price.
Yeah, so
you don't know what policy.
So yeah, this class exists to provide a price that has provably had GST applied to it. That's the point of the class, and it does that. So and in that case, this is a tool that it needs to do the job of providing a price that has provably had GST applied to it. On the other hand, it's taking the price of the constructor. So what that's saying is, I do not care in the slightest which price I'm acting on. Do not care. Not a problem. Now, here's the alternative, which is probably something that has occurred in every single one of your minds, and that is a tax price. So now we have a tax policy that you put in here in the constructor. Is that better?
I think so.
Sorry, what was that?
Because you can change the policies
Sure.
for different regions, and you can still make this work.
Okay, so yes, because now you can change the tax policies.
Yeah.
Sure, yeah, okay. Yeah, anyone else? Does it depend? Like, if it were to depend on something, whether it was good or bad, what would it depend on?
Wouldn't we need to?
Oh, speak up, sorry.
Wouldn't we need to keep on checking null checks for this parameter?
Oh, forget about nulls. There are no nulls. in my world.
What about time?
What about time?
Before a GST change, after a GST change?
Oh goodness! It is what it is, right? We're not. It's a price, right? do the prices? Last time we went to a shop, did the price have a time on it? Like, it's a price.
The price would completely depend on GST or the tax policy, right? So whatever the tax policy is, you get that price. I mean, here you just have this one.
Yeah, sure. So, okay, so I'll tell you my answer. And again, it depends. It depends what you want to do. So if you want a price that's just a GST price, that is a valid thing to want. And here we have a more flexible thing. But we're paying a price for this flexibility. It's not free, right? Because now there's more configuration we have to do. If we want to make a tax price, we have to choose the tax policy every time we create one. So then we're back at this problem from the early slides where the thing that we probably only want to choose once or a small number of times for the application, and we've got to keep supplying it over and over and over and over again for the same reason. So that we're not in a good place. And so then to get around that, you need something that lets you partially apply the constructor. And so what you end up with is something like this, like a factory that lets you fix the tax policy, and then you can spit out prices just by providing the other estimate. Yep.
So are you suggesting scattering the logic through all these different classes is a code spell?
The question was, am I suggesting that scattering the logic through these classes is a code spell? No, I'm not. What I'm suggesting is that there is a price to making everything hyper-configurable. And that's not necessarily a thing you want. Now, if you remember the justifications for the dependency injection frameworks, one of them is everyone hates factories. So here's a factory, but the reason we have a factory here is because we added that complexity of having that extra parameter. You don't have to parameterize everything, right? So some people have this mentality of, they're scared to use new, they're scared to do their own thing, so every single thing gets passed in. And that leads to complexity, that leads to factories. That leads to this problem that doesn't even need to exist, for which we need DI frameworks to help us with.
But it's a question of separation of concern, right?
Yeah.
So if we want to test the text price class and you fix the text policy inside, then our unit tests are going to assume that the text policy has a certain outcome. And if the text policy changes...
Oh, do you mean in the case of the GST price? So the question was, it's a question of separation of concerns. In the GST price one, when we test it, we have to assume the GST policy being this or that.
Yeah.
Sure, that's true. But again, all you can test is the point of a class. And if the point of a class is that it adds GST, then the only way to test this is checking that it's added GST, and yes, that implies knowledge of what that GST is. So sure, that's it's the swings and roundabouts here. So I can think of code I can think of code bases where honestly this is what we want. We're not going to change it. The GST is not going to change, and if we change it, it's probably got like a static variable or something in the GST policy class, and we can change it there and redeploy the code.
So how will you make this class work for different policies? Will you make different GST price for different policies?
So the question is, how would you make this work for different policies? You wouldn't. Again, it's a trade-off. If you want that flexibility, you do this, but you pay for that, and you pay for that by having all this malarkey. Do you want to pay that? Maybe you do. Maybe that's fine. You tell me what you want, but it's not free.
So just to clarify, you're saying, though, for the purposes of this example, we've got a fixed policy that's just a tool. The policy is a tool to help us calculate, because that's what the GST price needs.
Yes. So the first one,
we don't care about
the policy is just a tool that we're using to do our job. And the second one, we're saying, well, actually, we don't care what policy it is. We'll just apply a policy. But with that extra degree of freedom comes the extra responsibility of putting stuff in there.
So
the extra arrangement.
So if you don't require it, we should not unnecessarily make it complex. That's what is your point, right?
Yeah. Because what I see a lot of is classes where everything is swappable. And because if you remember, every time we see the class constructor, what we're saying is, we're making a statement that we do not care in the slightest which instance we're getting in the constructor. we are doing what we do. We're fulfilling our responsibility without caring which thing there is. And often that's not true. Yeah.
Isn't that what interfaces are?
What interface for? Yes, exactly. Yeah.
Interfaces bad though? Or?
No, they're not. Interfaces are great. I love interfaces. The point is though that you don't necessarily, and you don't want to reflexively dependency inject every single field in your class.
Yeah, I get it.
Like you want to say, well, is it my responsibility to do things this way? You know, often the name of the class will have a particular meaning, like GST price or something. And, it makes a statement about what it's for, but the implementation will totally belie that because it takes no responsibility for anything that would do that thing. It just says, oh, you give me things and I'll do things with the things that you give me, and assuming the springs all been wired up right, then I guess it'll work fine. And then you only see problems with that in the end-to-end tests with all the spring context and all that malarkey, which I hate and you should too.
Excuse me, can we go to the previous slide, please?
This one?
No, previous one. Yeah.
Yes.
Here, we are creating GST policy, okay? And you are thinking that, so most of the time when we solve a problem, business problem, so there's one of the design principles is your class should be always open for enhancement and closed for modification. So today I developed my application thinking GST policy is this, okay? And then I have created a new. And tomorrow, let's say some changes comes in the policy, then somebody has to go to this GST price class and modify it,
Yeah.
So that means we are actually modifying the code, which we have been told not to.
Okay, yeah, sure. So the comment was the ideal is closed for modification, open for extension, and here, because we're specifically choosing this GST policy, we have to go in and modify the GST policy instead of adding a new thing. Yes.
The point you're making.
You can put in that extra flexibility. It's just you pay for it.
Yeah,
it depends what you want.
But we'll be
right?
saving a lot because when we solve it, in this example, it might be a valid scenario, but when we solve a commercial applications, the changes can come over a period of time.
Well, this is very real. This could easily.
Yeah,
test
but
a commercial
tomorrow and
application.
after a year, GST policy change, then somebody, the developer has to go and modify your code,
Yeah. So.
I'm just trying to put
It's,
it
yeah,
I'm not saying it's valid.
you're weighing against this. So, like specifically because we know Australia and we know our GST has not changed since 1998. But we know this is not going to be a thing that needs to be altered very often. And in that case, it's not expensive to change the GST policy in the GST policy class and redeploy the code. And this is unaffected. This is like, well, actually, I don't care what the GST is. The GST policy decides all that business. I just want to apply it.
So because if you see our application, most of the time happy case scenarios, if we talk about the happy case scenario, for example, it says 98, it has not been changed. What if it changed? Okay, so most of the times our happy case scenario, the code is small, but extra code we write to cover this edge scenarios or to cover this negative scenarios and all kind of things. Okay, so for example, if GST policy is never going to be changed, then this is perfectly fine. But after 10 years or after 15 years, if there's a possibility of change, then somebody has to go and modify it.
Yeah. So you're saying, it might be unlikely that this changes, but then when it changes in 10 years or whatever, then you're going to have to change some code. Sure. But otherwise you're paying up front. And we're not supposed to pay for things up front, right? We're supposed to be lazy. We're not supposed to solve the world's problems in the way that we design our code. That's where complexity comes from. Comments?
One question. How can I test GST price without testing GST policy?
Yeah, sure. So I think, and I'm willing to hear different opinions on this, but I mean, I think the only way to test this is to check that the GST has been applied as decided by GST policy. So you might directly use GST policy dot rate or something, or whatever that stuff, whatever is offered there. So I'm not saying there's not a better way to do that, but I don't see an alternative. If the point of this class is to apply GST, then that's what you have to test.
Yes.
But we might choose a different point for the class if we don't like that. If you know what I mean.
So
What is expensive? What's expensive in terms of
code lengthiness, maintenance? Or what
Speak up, sorry.
So when we say expensive, what do we mean by that? Is that in terms of maintenance, in terms of...
Did I use the word expensive?
Oh no, cheap.
I don't like it.
I guess like the factors that the variables that we're dealing with here are maintenance effort, simplicity of the code, flexibility of extension of future extensions, rippling change, separation of concerns. But they're not all the good things. We can't have all the good things all at once. We have to pick which one we want. We have to make trade-offs. Yeah.
So another benefit, and to your point, when tests fail because of spring auto wiring or that application injection stuff happens, this won't fail for the same reason because your GST policy is instantiated here and it can be tested here.
Yeah, it's not Spring business. Spring has no business doing that for us.
If you're injecting it using Spring, there's a possibility you're injecting it with different parameters than what you expect. Your unit test might have a policy with brackets. What you're injecting in production may have other arguments going into it, right?
Yeah, so you're saying if we use Spring to inject it, then it might have things that we don't expect.
Yeah.
Like, it's just a blurring of responsibility. Like, if we choose our responsibility to be, it's a GST price, and we're leaving it up to Spring to provide us the thing that makes it a GST price, we're not doing our job. We're delegating it to some unknown stranger. We're relying on the kindness of strangers, and that's not a good way to write code. It's not a good way to have a class as a locally reasonable, self-contained universe that does one thing, which is the ideal for all of the bits of code that we write. Have enough time? Whoa, look at the time. I've got to move on. Okay. We're going to run over time. Okay.
Let us talk.
Shouldn't have let me talk. Cool. So anyway, this is that section. This is the point. Don't just lazily, reflexively turn everything into a dependency because you pay a price. It makes the software more complex. If you make everything a dependency, like your code is going to be complex. It's going to be hyper configurable, and it's going to be a big pile of things. This is stuff that's really not easy or fun to maintain. And you will need a DI framework to handle the complexity. So I guess my whole point here is, if we think a bit harder and don't do that, maybe we don't need a DI framework at all. So yeah, new is fine if it supports our reason for existing. It's all about responsibilities. It's not about new, it's about responsibilities. Dependencies ain't free. So going back to our rentals example, so we see that the rent video functionality there are three dependencies here, and this uses all three dependencies. It's a class that only does one thing, it's only got one method, and it exactly uses the function. All of the functionality that we're given is used, and we don't need anything else. So that's fine, that's a perfect little circle there. But what if later on the code changes, someone comes along and says, oh, actually we need this extra feature, we're going to rent a video with a popcorn deal, and to do that, we're going to need a popcorn machine, and so we pass that in, and now we've got a new thing. So I like to think of it sort of like a diagram like this. So the little black dots are dependencies, and the blobs are the functions, the methods. So rent video uses the three dependencies there, but then we added a new thing, and now it adds a new dependency that's not used by rent video. And for argument's sake, let's say it uses a subset of the dependencies of that one. So now we have a bit of a more complicated class, and crucially, if you want to run rent video, you now need an extra thing that is not required strictly to do rent video. All that functionality is locked in a lockbox, and the key just got bigger and more complicated for all of the things here. And then someone comes on and adds another thing, and again, now we've got more complexity. If you want to run any one of those things, you need all of the dependencies.
You can use a builder pattern there, so you know which dependencies you want to use when you do the platform.
Yeah, so the comment was you can use the builder pattern so that you can use dependencies, or yeah, I'm not sure what to make of that. How would that work?
Well, you just pass in your popcorn machine, your video rental, check your notes, and then you're fine.
So you have like a with popcorn rental, and it returns a new thing that can do the new.
No, it's just the same thing.
So the dependencies that you didn't need for that test would be null.
Would be so for the tests, you would just leave the dependencies null,
yeah.
And you would, yeah. I mean, sure, but there's this idea of correctness by construction, and this is the ideal for writing a class. You want to be correct by construction. The fact that you have a rentals means that you can use it correctly. That there is no possible way to set it up in a way that it's broken. And if you've got this thing where you can leave stuff null and you can like do things that break the object as a whole, and you can get in there and fiddle with it and turn this thing off and like twiddle that thing and snip these wires and rejoin them there, and then it works in just the right way for this one test. That's complicated. It's brittle. You don't want to be there. That's not the place you want to be. Yeah. So I mean, what you're suggesting is we have a mutable class that is not always capable of running any one of the functions that it supports, and if it is capable or not, you don't really know. It depends on its history, depends on who's called the setters and what's happened. You don't know, and then hey presto, we've got a null pointer exception in the logs. Where did it come from? I don't know. Like this is not a good place to live. I've got a whole section. Sorry. I've got a whole section on why setter injection is a bad idea. So maybe let's move the setter injection stuff to yeah, so I think... Say that again, sorry? Yeah, so yeah, dependency injection frameworks like Spring make it easy to supply all those things. I'm not disputing that. I'm saying it's not a good idea for it to do that or to make it easy because of responsibilities. So yeah, and so over time the boundaries change because all these dependencies are lying around. Things that previously only needed a small number of things will just start to use the stuff that's lying around. And so all of these bits of functionality become more entangled, harder to separate, and harder to deal on their own. Now, how many times have you wanted one of these things to do a job, and you can't have it because it's nailed to all this other stuff? And you've got to find somewhere creating this whole thing and then separating all the other things so you can just run this one thing, and maybe you can have extra special knowledge about exactly which dependencies it's using and only provide those. But that is not a good idea. And yeah, and if you've got getters and setters, it's even crazier. So what I'm getting at is this is how code bases go to hell. You want coherent classes that exist for a clear reason, and they don't sort of keep growing and have ever more complex dependencies. And the thing is, DI frameworks like Spring make it really easy to pretend that it's free. Like it's so easy. Like you just add a new dependency and auto wiring just makes it happen. You just go on your merry way, you put your functionality and you go out. But you've paid a price because your software is more complex now. And it's harder. The keys that are required to unlock these lockboxes are bigger. It's harder to compose functionality, it's harder to separate things, it's harder to test things. And if these frameworks were not there, I would suggest that people would be less likely to introduce this kind of complexity so easily. I think I'll move on to the next section because we're running over time. Setter injection is malpractice. Yeah. Who likes setter injection? Who will happily defend it? I hope there's someone. Oh, come on. Otherwise, I'm preaching to the converted. Okay, so this is our rentals class now with setter injection. So we have a nullary constructor. You just create it, and then you go set to put all the dependencies in there, and then you can call rent video. There are big problems with this. So we have invited a whole lot of complexity into our house now. It's no longer correct by construction. You can create a rentals, but you can't use it. Because someone's got to come along and they've got to call these things, and depending on how it's implemented, maybe they've got to be implemented in a certain order. Do you know, you have an instance now of rentals, do you know they've all been called? Do you know it's set up? How many different states could it be in, depending on the order of these things, whether they get called or not, or when? Who knows? You call rent video, you get a null pointer exception. Where did it come from? I don't know. The number of states that we must consider now is complexity. It is stuff that we have to fit in our head and consider when something goes wrong in our software. And we have just invited this into our house for no reason at all. If we have private final fields and we initialize this in a constructor, then we don't have that problem. So, I mean, why would you do this? I don't know. And so another thing is it essentially confuses two concerns. Because now our public interface has things that we use the class for and things that are applied to construct it. And so we have this thing here where both the usage stuff the programmer needs, and we've got the construction stuff that we need to set it up, or that Spring would use if it's setting it up. But they all live together in the public interface. So this is really, really bad. It's analogous to a supermarket where you rock up at the shop, you want the shelves, you want to buy stuff from the shelves, you don't want to know there's a truck out the back with a pallet full of tomatoes. You don't even want to know it's there, it's none of your business, you don't care. The truck driver dropping off the tomatoes, he doesn't need to know about the shelves, he just wants to drop off his pallet full of tomatoes, sign the invoice and collect his paycheck and go home. It would be a grievous error to combine this. If the shoppers had to know and interact with this supply bay out the back, or the truckers had to learn where the tomatoes are in which aisle, like this is very bad. Now there exists someone, the people in Coles management up high, they need to know about the shelves and the supply. But there is a place where somebody needs to know about both those things at once. But it's not the shoppers and it's not the truckers. This is clearly analogous to our software situation. Construction is just a totally different thing from the usage of a class. So setter injection is a really bad idea. Now we'll get to the interfaces. So a few people have mentioned interfaces, rightfully so. Interfaces are great. I love them. I just think they're so uncontroversial that this is why I haven't talked about them so far. So really, like rentals should really be an interface. That's the concept. And it just has that method signature. And so now we're just depending on that usage signature, and we don't have to worry about the implementation. So yeah, so interfaces are what you want to do there. And to their credit, DI frameworks are quite friendly to this style of coding. Yeah. However, they're also friendly to setter injection, which is a really bad idea. Yeah. It shouldn't be easy in practical at all. It shouldn't be so easy to do as it is. Yep. Anyone want to say something about that? Yeah.
So if setter injection is bad,
yep,
and we use construction injection,
yep,
should you test that all of those things that are injected are not null? Otherwise, isn't that the same outcome as setter injection?
Okay, so the question was, if we're going to use constructor injection, not setter injection, should we test those things aren't null? I'm going to say no. And it's kind of a hygiene. Like nulls are just such a bad idea. And yes, we can test every single thing isn't null, but it's better to just not use null, and then you don't have to have these defensive checks all through your code. And you can put in like anti-corruption layers at the boundaries of your system, like we're getting something from somewhere else, and maybe that's null. Like the Java libraries have lots of things that return null. So you put in like a thing there to protect against nulls entering your system. But then you just don't use it, and then you don't have to check for it everywhere. So I think of it as a bit of a smell if you're just constantly, checking your shoes to see if your feet are still in them, or check that our arms haven't fallen off, or it's just we can just assume that's that we got basic hygiene.
But you could argue the same. You could say we assume that when you're using this class, you call all those setters as well.
Yeah, that's a much less sound assumption, though. I mean, that's true, but one of them is leaving the gate wide open for all kinds of craziness, and one of them is not. Yeah. Sure. I'm going to go on to the next one. So this is my last section, and it's a little bit more esoteric than the last ones. And I'm going to introduce some ideas that are quite popular in the functional programming community, where I'm involved a lot, that really affect this in a way that's interesting. And I'm not saying drop everything and start using Haskell. I'm just saying it's nice to be aware of how this is addressed in other ecosystems. So if we take, let's say, a payments class, and it takes a payment gateway, and then it does a thing, it does a charge, that takes a price, and presumably uses the payment gateway to affect that. I'm going to massage this signature a little bit. So we're taking two arguments here, gateway once when we're constructed, and then price however many times, each time the charge gets called. Now, if we change that into a static one that takes the price and the gateway, is that the same thing?
It's better.
Well, it's that thing again, right, where we have to constantly provide the gateway every time, even though we only really want to choose it once at the start of the application. So it's like that, it does have that problem that we talked about back at the start now, but functionally it's identical. We're still taking two arguments, and we're doing a thing that uses those two arguments. So we can do that. Do you agree with that? Is that fair? Okay, so we're going to massage it a bit more. now instead of taking a price and a gateway and returning a receipt, we're going to take a price and return a function that takes a gateway and returns a receipt. So this is called the curried form of that method. Is this the same thing? Yeah. It is the same thing. Is everyone satisfied? Okay, so if we wrap this up as a data structure that needs gateway of receipt. So now we can add some methods to needs gateway to allow manipulation of that type parameter. If we have a needs gateway of receipt, we don't have a receipt. Like you'd need to provide a gateway to get the receipt. But what we can do is use what's called continuation passing style to provide functions that say, well, if I had a receipt, this is what I would totally do with it. And that might provide another result, which we also don't have. And you say, well, if I had that result, here's what I would totally do with that. And so you can keep composing these fantasy programs of what you would totally do with values if you had them. And then at the very end, you actually provide the gateway and it all runs. Now, this is not all free kick. Like there's pros and cons to this as well. But you may not be aware that this style of code exists as well. So this is called monadic code. I'm not going to explain how it works. I just want to give you an idea of how it affects the problems that we've been talking about. So for argument's sake, we might call charge with $0.05. We don't get back a receipt. What we get back is a needs gateway of receipt. And we call flat map on that. So this exists in Java, by the way. You can do some of the stream API. You can implement this thing in Java. And then we're saying, if we had a price, we would totally do something else with it. And what that returns is a needs gateway of the next thing, the result. And if we had a result, well, we would totally turn it into a string. And what we get back at the end of it is a needs gateway of string. We still haven't done anything. All we've done, but we have composed and rearranged the functionality. We've written a program, we just haven't done anything yet. Which is, yeah, come on.
In the hypothetical, is needs gateway in implementation of stream? Like the implement stream to get these flat map?
It's a fancy name for a function from gateway to
yeah,
receive.
okay, so you just
really, it's just a function. Right?
Yeah. Yes, the flat map and map aren't on the function.
Yeah, you can implement them. I mean, you could, if you're writing your own class, you can put whatever methods on it you want. But Java has it on the stream API specifically. It doesn't have it on its regular collections.
Yeah, that's why I was asking. Yeah. Point is
option. I don't think they put it on option.
No, it is on optional now.
It is optional now. Oh wow! Oh wow! There's big battles on that. The functional wings won. Hooray! Okay, so all right. So this style of code is called monadic code, and languages like Scala and Haskell actually have really nice syntax for this. So that looks like it's kind of imperative code. Like, we do this, then we do that. This is a bit ugly in Java. I don't know if I do it this way in Java, but so it's not practical in every language to write code like this, I think, but it's a thing that exists. And so what we might get is a needs gateway of the final result. Like we've written our whole program in this data type, and then at the end we actually run it with the actual gateway, and then we get back an actual final result. And what this does then is we don't get that object creep. We don't have any of these code hanger objects that have sort of bubbled up through our system, because the only things we need to provide is the hard I/O boundaries. And I mean, even in a huge system, are you going to have any more than about 20 of them? I can't imagine. Like you might have 5 APIs that you're calling or something, and 2 databases, and a system clock, and a false. Like I can't even. It's not going to be that many things if it's just the hard I/O boundaries, the things that you supply. So then you don't have a wiring problem at all. And it's not a trade-off we've made. It's not a we've robbed Peter to pay Paul or put some stuff under the rug. It's gone. So it turns out that the very existence of that problem that we were trying to solve with the dependency injection frameworks, it's an artifact of coding that way and using that means of providing flexibility in your code. Here the flexibility is all provided in that return type, in that needs gateway return type. So here, I mean, what I'm not saying here is that if this would no longer be needs gateway, this would be needs all that stuff. So this, I mean, there's pros and cons to this as well. I'm not saying it's a silver bullet. I'm just saying that there exist ways of coding that are popular in other language communities where this problem doesn't even exist.
Ken, is that still follow on in this function signature follow out? Once you're returning kind of at the bottom level, does that mean that's going to follow up at every level?
Yeah, so the question was, does this mean it bubbles up at every level? So yeah, when you're writing an application in monadic style, you usually pick a signature that's going to be the language, the common language in the application. So it wouldn't be need to go where it's a bit too specific. You'd probably say app action or something like that, and that you're using that, and that's what you're doing. So it means this is one of the prices you pay in using that style is you sort of need to speak that language, which means a lot of your return types that do stuff have this return type. You don't just return a banana, you're returning an app action of banana. So that's one of the prices of that style of code. But I wouldn't call it bubbling up, I just call it, all the things that participate have to do things a certain way.
Can you show the previous slide and just keep talking?
What was that, sorry?
Can you show the previous slide?
Cool. So what's really happening here is because we're separating the arrangement of the code and the declaration of the code from the execution of the code. And it turns out that a lot of the dependencies that you need, you only need it to run the code. You don't need it to arrange the code and compose the code. So this is a big deal in functional programming, having that separation of concerns. So that's just, this is a thing that, that is common in another language community. So I think it's nice to just be aware of this sort of thing. Yeah.
To learn this monadic style, would it be useful to write your initial code with the with gateway comma result instead of needs gateway wrapping things up, just to leave the function type as a return signal?
Oh, just to leave it like this?
Yeah, so leave it like that, learn how to write it that way, and then simplify the type.
Yes, the question was, is it helpful to just do it this way and learn it? It will be helpful in that you will learn why this is very painful and you want to wrap it up in something else that does the hard work for you. if that makes sense. Yeah, this style of code is not a whole lot of fun in Java, and there's a lot of things that I use this style of code in, say, Scala for that I wouldn't use it in Java, for instance. So, there's pros and cons, and it depends on your language environment.
Does erasure get involved with Java? Like, as in, does that become a hindrance because...
Erasure's good. That's a good thing.
Yeah, cool. I'm just,
there's nothing wrong with erasure, and that doesn't get in their way at all.
Yeah.
No.
All right.
Yeah. Yeah.
How do you suggest handling umbrella services like logging and analytics?
In just a general OO way. So the question is, how would you suggest handling umbrella services like logging and logistics? So yes, I would treat them as dependencies. I also think they should be treated as first-class requirements of a thing, and that's how I treat it in the example way above with the rentals. Notice that the logging, it didn't say log some string, because logging a string, that's a separation of concerns issue, because the string is assuming knowledge of the person who's going to read the string. Is it going to be an end user that sees it on an error message? Is it going to be a maintenance programmer that sees it in a log? Like, most classes have no right to know that. So what you really want is like some enum or something that's like, what I'm logging is this logical thing, which I had a error messages dot rental failure or something, or whatever. It's a signal, and then something else will be translating that. So for instance, the logger, we could use the decorator pattern on that logger. As far as we know, we have a logger that that we're giving these flags to, but on the inside it could have a regular log4j logger, and it knows how to do the mapping from that to the user strings using the thing that's responsible for knowing user strings, because it knows who the users are, if you know what I mean. But we don't, like none of that, we don't know any of that here, but in the actual code that uses the loggers, you treat that as a fully fledged, well, this is what I would do. Treat that as a dependency like you would with anything else. Treat it as a thing that you want to test, that your code is responsible for. And you can use these sort of the decorator pattern or something like that to lay out these extra concerns and have it all plugged into strings and log4j and all that sort of Splunk and all that malarkey. Does that answer your question?
Yes.
Yeah, sure. Cool. Last slide. Conclusion. Passing arguments to things is not very hard. Wiring together applications is not very hard. And for the most part, the answer to this problem of having this wiring code is have a central place where that belongs and nowhere else. Have a very firm idea of responsibilities, so that nowhere knows that it's in the application except for this one place. and then use good software engineering techniques so that to reduce the number of things that need coordination and arranging. Because it's a smell. If every single thing, if you're wiring together the bricks in the house wall instead of wiring together the floors in the apartment or wiring together the rooms in the house, that's a smell. And it probably means that you're not thinking hard about responsibilities. It probably means that you're just reflexively injecting everything because you never have to have an argument about that. Everyone is convinced that it's a good thing that you parameterize everything and Spring will handle it for you. But this problem doesn't have to exist. DI frameworks, they are too complex. I claim that it's a $50 solution for a $5 problem. You don't need them. And again, you can write perfectly fine code with these frameworks, but you don't need them, and they tend to lead programmers and teams towards sloppy design patterns.
So proper functional programming can do without IOC?
Yeah. So when I was at REA, I wrote Scala code for about 5 years, and I never once used an IOC container. Yeah.
Because with Scala, they've got the implicit parameters. Is that the way, or is that completely different?
That's a different thing.
Yeah.
I have opinions about it.
It's almost,
but that's a rant for another day.
Yeah, that's fine.
Sure.
Time.
So, I'm not saying like, oh, it's bad. Everyone go to functional programming, drop everything and use Haskell. That's not what I'm saying. I'm just saying, just be aware of the trade-offs of the tools you're using. Learn the pros and cons, and think hard about the responsibilities and the way that you're using the tools that we have. We can write perfectly fine code in Java. We just have to think hard about our responsibilities and be careful about where the tools that we use are leading us in the way that we write the software. Yeah, that's my talk.
All right. Is there any more questions for Ken? You might borrow your computer while we're. I'm just going to go do the raffle.
Yeah. So should be a file recency. We'll probably find a window.
Oh, do you have a just a web browser?
Oh right. I turned the Wi-Fi off, so let's turn the Wi-Fi back on.
I have. It's notifications.
I turned.
So cool. Let's take this slide selects.
Well, don't say this. Are you got it? Yeah, it's up. Okay, good.
All right, cool.
Yep.
It's just loaded. All right, actually, Ken, you can come up here.
Oh, sure.
You can go and press this button for us.
Unbiased. I hate these. These pad things got worse in the latest Macs. Hey, here we go. Fabrice, good night. That's from what's who the from. Fabrice.
He's asking questions.
Again. Sorry, Fabrice. That's all. Francis Ridford.
He never shows up.
Yeah. Uday Karan. Hooray!
Afterwards, we'll give you a IntelliJ license extension of whatever license you've got if you've got one already. Before everyone goes, I just wanted to present Ken with a token of our appreciation.
Oh, you're really
MelbJVM footy. Probably own a footy, and there might be a chance that you do.
No, I own two.
But you probably bought some of the biggest people as well, JVM. So,
thank you so much.
Thanks everyone.
Well, thanks for coming, everyone. I appreciate it. Oh, thank you very much.
No worries. Just put the thing, we should back up.
The short track rider.
Oh, thank you. Well, it would have been very smooth. Everyone would.